Hello, chemistry class. It's me, Miss Covarrubias here. I'm going to teach you about international system of units. The first ones that we're going to talk about is the 6 basic units and what they measure. So we have meters for length, grams for mass, Kelvin for temperatures, time is going to be measured in seconds, moles for quantity, and joules for energy.
And hopefully this is kind of a review for you. I know that a lot of you know that meters means length, and really where we're going with this today is we're going to be talking about how to use these units in conversion factors and in dimensional analysis. And in that case, these are I guess the standards or the base unit, the ones that are kind of our central normal one, okay? And so these are also thought of as our base unit. Okay, so this is where we'll be starting, and this is will help us on our chart.
We'll talk about ratios first and why we use conversion factors. The reason we use conversion factors is because the ratios are going to be equal no matter what. So we have a little example there for you where it's 1 gram is going to equal 1 kilogram. Same with, we'll go 60 seconds is equal to 1 minute.
Right, and so really these we can write out. So these are all equal, but we can write this out in ratio form, and all 100,000 grams is equal to 1 kilogram. And really, you cannot use a ratio in dimensional analysis, or it can't be a conversion factor at least, if it's not equal. So another example of this might be like 12 inches in 1 foot. These two things are equal, so it's considered a conversion factor. And there's a way that we can kind of figure out conversion factors that we don't know, but there's also some that we just need to memorize. So like 60 seconds in a minute, like Miss Aarons just said, obviously is one that we know, but some of these other ones, like 10 to the 6th is a micrometer or microliter or microgram. That's why we were talking about these base units. We can basically put any smaller or larger unit in front of it, make it change.
And these, it's going to be 10 to the 6th. They look kind of like 106, but that's supposed to be an exponent there.
Yeah, this is an exponent. So microgram, oh, why does it keep doing that? I should press the pen every time. Okay. So this is actually 10 to the 6th. So if you had 1 meter, it would be equal to 10 to the 6th micrometers, which means that there's 10 to the 6th obviously is, right, 1, 2, 3, 4, 5, nope, need one more 0 in there. So that's 1,000,000, so there's 1,000,000 micrometers in 1 meter. And same with this one, this is 10 to the 9th. So that means there's 1 billion nanometers in 1 meter, or there's 1 billion nanoliters in 1 liter. Because we can use any of those as our bases. And then pico, these are just the prefixes, okay? And we can put these on any of our base units. Anything else we can talk about this one? This one's pico. This is the smallest unit that we will use. And this stuff is like to measure the distance between electrons, or
something very, very small.
Very, very small, yes. All right.
So making conversion factors here, we're always going to look at what we're based with or what we're starting with. And then we can either go up or go down. We're either going to make it really, really small or really, really big.
And as you go down, it gets smaller, and as you go up, it's going to get larger. Okay, so those pico and those smaller ones would go down beneath here, but they don't go, they're not the very next one. You need to remember that. That's why you have to memorize them, because there's space, because we don't have a unit for every 10th place, because this chart goes by 10, so each unit is separated by 10. So 1 gram, there would be 10 decigrams in 1 gram, and there would be 10 centigrams in 1 decigram. Okay, so it's separated by tens. But a really easy way to figure out conversion factors is that you just put a 1 beside whatever you have. So if we have let's say we want to know how many decimeters are in 1 meter. Okay, so you would start out with 1 meter, and then you would move down, and as you move down, you're going to just add 1 0. So then there would be, in 1 meter, there are 10 decimeters. Okay, and then of course if we want to do in how many kilometers, okay, so you put a 1 right here, and you would add zeros clear until we got to there. So there are 10,000 decimeters in 1 kilometer. And so this unit, we can use it for any of the bases here, the grams, the liters, meters, temperature, moles. We won't be using these right now, but these for sure. So whatever problem you start off with, if you want to know how many of something is in something else, you just put a 1 beside it. So if we want to know in 1 centiliter how many milliliters there were, we'd put a 1 right here. The 1 can start anywhere on here, and then you just add a 0. So we know that our conversion factor then, 1 centiliter is equal to 10 milliliters. So this is a conversion factor because they're equal.
Yep. It's a ratio.
This one's equal, it's a ratio. This one's equal, it's a ratio. Anything else on this one?
I think that's it on that one.
Okay. All right, so dimensional analysis, what we do now is we take a whole bunch of these conversion factors, line them up all together, cross out all of the units, cancel out all the units, and then you do the calculation.
Yep. Whatever's left over would be your label then, so then your unit conversion would be over.
But the whole idea of dimensional analysis is this canceling out units, okay? So you have to write out your number and write out the unit all the time. Like, you can't just put a 12, otherwise you're going to be lost, okay? So when we write the given number, so you're going to have a problem and it's going to say, you know, you have 4 days or 6 days, and then that's the number you'd write with the unit, okay? And we're going to do an example of this. I just really want you to get the rules down here. And then you're going to draw a line to multiply by a ratio. So you're going to have, like, say our given number is 16 days. We're going to draw a multiply line, and then this is where we're going to put our conversion factor, our ratio, okay? And then the bottom of the ratio should always be the same unit. So before I even know anything of where I'm going, I can put days automatically on bottom because we want these two to cancel out. So this one's theoretically on top because anything without a ratio has a 1 underneath. And then wherever we're going, we put it on top. So
say
maybe
if you want to go to weeks.
Weeks. Sure. Or let's do something smaller like hours.
We could do hours.
Okay, so if we go hours, we know that in 1 day there's 24 hours. Okay, and then so as long as that ratio is equal, we're fine. Okay, so now if the number is on bottom, you are going to divide it, and the number is on top, you are going to multiply. So if we look up here, we know that 16 is going to be multiplied by 24 because 24 is on top.
Yep.
Now, like Miss Aarons was saying, what if we were going to weeks? So if we had 16 days, days would go on bottom, and there are 7 days in 1 week, because that's what's equal. So now days cancels out again. Now we're left with weeks, which is where we're going, and now you take 16 divided by 7.
Which will give you how many weeks left. You can see that whatever was left over is going to be your label for your answer as well.
Right. Okay. Anything else on this one?
No, I think we're good. Let's try some problems.
Okay. So this one is just a simple one. We don't have to find our unit. So how many seconds are in a workday that lasts exactly 8 hours? Okay. Oops. So let's get started with writing our given number. So
What we started with is going to be our 8 hours.
That's the only number in the whole problem. So we have 8 hours. We'll draw an X and a line. This will be our first ratio. We know that hours has to go on bottom. And we're trying to get to seconds, so you really want to try to figure out where you're going. Okay, so this is where we're starting. This is what our last unit will be. Now, me personally, I don't know how many seconds are in 1 hour, so I'm going to go with something I know here. And I know that in 1 hour, that there's 60 minutes. I know that for sure. And we can do this as many times as we need to. So we're going to draw another X with a line, and then I'm going to put minutes on bottom to cancel this out. And I'm going to go with 60 seconds on top. So now minutes cancels, hours cancels, so now I have 8. Since it's on top, we're going to multiply, and then it's on top again, so we're going to multiply again. So really our problem is 8 times 60 times 60. So our answer is going to be 28,800. Okay, now, of course, we have to apply all of our last knowledge from the last section. So we have 2 placeholder zeros. We only have 1 sig fig here.
So we're going to have to round.
Yep, so we're going to go 1, 2, 3, 4. So our answer, this one is going to round up. So we're going to have 3 times 10 to the 4th seconds. And then I box in my answer.
Make sure you're starting to label your answers, because I will count off if it's not labeled. You could be measuring anything,
right.
Measuring dogs or whatever.
Apples.
Apples. Okay, and then make sure you're counting significant figures. Sig figs are important. I've already started counting off for those as well.
Right. Units is worth half a point. Sig figs worth half point. Scientific notation worth half point. And then your answer is worth 1 point. So, and then your work's worth points. So everything's now worth points. That's for sure. All right, so let's start a little bit more of a difficult one. So the direction for an experiment asks each student
to
measure 1.84 grams of copper wire. The only copper wire available is on a spool that has a mass of 50 grams. How many students can do the experiment before the copper runs out?
That's a tough one.
It is.
Yeah.
I thought I'd give them a hard one. Okay, so to start off with, now we kind of have 2 numbers, so we have to figure out which one is a conversion factor and which one is the given number. Okay, so if we read this again, it says for the experiment asks each student to measure this much. So each student gets 1.84 grams. So that is a conversion factor.
Yep.
For every 1 student, they get 1.84 grams of copper. Then that would make this our given number. So we're going to start out by writing this. So I'll start right here, 50.0 grams of copper. Now, we wrote it like this. These can flip back and forth. We can use this, or we could use 84 grams of copper over 1 student. It's still equal. So however the units cancel is which one we use. So in this case, we'd be using this guy. So we put 1.84 grams of copper on bottom, 1 student on top, and then 50 divided by, because it's on bottom, 1.84. That's going to tell us the exact amount,
which is going to be 27.1739.
Okay, so this then gives us information of how many students can do the lab.
Yep.
Okay, so in this case, it says 3 sig figs and 3 sig figs, but can you have a 0.2 of a student?
Not really.
Not really.
I sometimes wonder.
Right. So we're going to cross these out, and we're going to say 27 students can do the lab. Boom, that's our answer. On On Monday, we're also going to be talking about how density can become a conversion factor because it is grams over milliliters, and whatever those numbers are will be equal. But otherwise, the rest of the entire semester we'll be using